This is a proof of concept video about the power of the scaffold method, focusing on the units that are within an equation. I want to take a couple pretty much well-known formulas and work on the equations only looking at the units. Let's take Newton's third. F equals ma. And I want to pause for a second and think about what units each of these letters stand for. Force, let me first say this equation as if I was speaking over a phone. Force equals mass times acceleration. Now let me be clear about this. Force, what are the units of force? Mass, okay, grams, kilograms, pounds. Let's keep it simple. Let's stick with grams. Acceleration. Acceleration, very physicky. The meters over second per second. The change in velocity per second. Very physics terms right there. Let's write these out into a scaffold. Mass, we're going to say, is in grams. Acceleration is meters per second per second. I'm not going to put the dot in there. Okay. Now, as I have these written up here, just to put parentheses around what unit is represented where. This is the form of F equals ma with the units written in here. Since this is an equal sign, since equal signs are understood that the magnitudes and that the numbers and the units match on both sides of the equals, these are the units of force that Newton very humbly named a Newton. Force equals mass times acceleration. These are the units for newtons. Grams times mass divided by seconds squared. Seconds times seconds. No units cancel here. Let's do the same thing with another well-known equation right here. E equals mc squared. The relationship between mass and speed of light and energy. The energy equals the mass multiplied by the speed of light squared. Now, let's think about this. What are the units of E? Are they the same as force? Is this the same as F equals ma? I can look at the units and answer that question, how they're different or how they're the same. Mass is a unit we're going to give in grams. The speed of light squared. Now, speed is a meters per change, the change in meters per second. So it's meters per second, meters per second. This is the velocity squared, speed of light here. We can see that these are not the same newtons. These are not the same units. They're pretty similar in the denominator, but they are different in the numerator. This can be abbreviated down to grams meters squared divided by second squared. This is grams times mass divided by second squared. I've used these orange parentheses so you can see vertically the relationship. I want to erase these orange parentheses so that way you can see a lateral relationship between these. Because these are no longer related, I'm going to erase these up here as well. Okay. Now I'm going to look at these scaffolds. Grams times meters divided by seconds. Divided by seconds. Watch how I draw these parentheses laterally. Okay, kind of making that fit in there. What's in parentheses laterally are identical units. This Newton defined as a Newton. This E here is Newton meters. E equals mc squared looks and feels very familiar to F equals ma, and 80% of it is. Note that the units here, E equals newtons times meters, can be broken out or pulled out of E equals mc squared. Thank you.